atmosphere environment. And I didn't tell them that it was for coffee because I didn't want them to think. I just wanted them to give me an oven where I could do this. And they found an oven, this small one. This is an oven made to heat up metals to high temperatures in a nitrogen environment so that you don't get a crust on the metal. So I thought that will work. So we attached a nitrogen bottle and then added a flow meter so that I could get some control of the flow, because this was a huge oven and I couldn't see anything. So I needed to just make sure that at least the control, it was not a nice roast, but at least it was controlled. And I could make a roast with oxygen and one with atmospheric air. So I just needed to make sure the temperature was the same, and also make sure that the flow of nitrogen in the first roast and the flow of atmospheric air in the next one was the same. The flow just needed to be the same. So we attached the compression air and had a small flow meter between the compression air and the oven, so that the flow of atmospheric air was the same speed. And I did triplicates, so I did 3 roasts with nitrogen and 3 roasts with atmospheric air. And as you can see, it was a really, really small batch that I added like this. So it was far from a good roast, but I just wanted to see if we could tell a difference. Wenda was really interested in being able to taste this, and so would I, but this is not really what's called food grade, so I'm not sure what was in the oven before, so we couldn't really taste it, and also the batch size was much too small. So what we did was a pure chemical analysis of the volatile aromas, comparing these two, and we only had, Wenda was giving these data Thursday last week, and the data was not really conclusive. As a scientist, you have to admit that they are interesting because they actually provided some interesting differences. But our problem was with this crude setup, what has caused the differences? I've done what I could to make a standardized roasting, but we need much more time and resources to really dig into this. So Mikael Aelin, an aroma chemist, was analyzing the data, and then I hired Line Knudsen, a really skilled student, to get the data and make a small report for Wenda that he got Thursday. And we had a meeting, and the problem is it was not really conclusive, but Wenda has got a lot of really interesting thoughts about this project, but also the problem as such. So that's the background. We would have preferred to have a really nice and conclusive study, but we have done everything we could to just have something. And to have Wenda here is a great pleasure, because often if you talk to aroma chemists, they are really skilled at analyzing chemical aromas with different types of equipment. But they don't know anything about tasting or smelling or anything, actually. So that can come as a surprise. So, people at sensory science, they know a lot about tasting methodology, but not a lot about chemistry. But Wenda is the perfect combination, because he's got an aroma chemistry background and is now professor at sensory science. So it's really easy to talk about these two different aspects, the chemical and the sensory, because he's been so long in exactly these two, with a leg in each world for a long time. And that's rare, actually. And I didn't know that before, but I know now. So I think that was it. So I would like Wenda to come and take over.